So guys, here's the setup for the diffracting gradient. The setup is slightly different from the sketch we had on the board. So normally for the sketch we had on the board, the light source was supposed to be behind the CD, right? You had to go through the CD and project the beams on the screen. The screen here is this white surface right here, okay? This white surface with a ruler taped to it is our screen. The ruler actually is a screen because we need measurements. So how is it slightly different? The light beam is actually here. This is your laser because we need the light to reflect off the grooves. As you can see, the light is hitting the grooves of your CD. So we had to put the light source in front of your CD. But that notwithstanding, the key thing, the essential stays the same. You have your CD, a certain distance. You see the ruler right there? It measures the distance from your CD to the screen. That distance, ladies and gentlemen, is 1 meter. It corresponds to L, uppercase L. Distance from the grading instrument to your screen. That's your uppercase L. Remember, we're trying to solve for D. D is the size of the grooves on the CD. You see, you cannot, no matter how I zoom, you cannot see those grooves. You have to use the physics to compute that. Now let's look at the screen. This is your screen. I'm going to temporarily turn off the light so you get to actually see that brightness. So bear with me while I go turn off the light to help you see better. All right, so what you can see here is there's a very bright spot at the center. That is your central maxima. To the left, you see another bright spot that is n equal 1. And to the right, you see another bright spot that is n equal 2. All right? That is your screen that I showed you on the board when I did the quick video tutorial. So what we're going to do, I'm going to zoom onto these dots so you can read off the measurement and use them for your calculations. I'm going to turn on the light. I'm going to go to where N0 is. Spend a little bit of time for you to read off the measurement. I'm going to go to N1 and on the left and N1 on the right so you can have your values for what we call was the distance Y, okay? Remember, Y was the distance between the central maxima and all the other bright fringes. So hold on for me to turn on the light. Okay, right now I'm going to zoom onto, I hope it doesn't interfere with the light source. So here's your n equals 0. It's up to you to decide what what position n equals 0 is. Here's your n equal 1 to the right, to the left, I'm sorry. The center of this spot. I see 3 lines, but I want you to focus on the one in the center, okay? That will be, right, your n equal 1 to the left. And your n equal 2 to the right will be this guy. You focus on the center there. That's your n equal 2 to the right. All right? I'm sorry, your n equal 1 to the right, okay? So that's n equal 1 to the right. That's its position on the ruler. N equals 0, position on the ruler. And n equal 1 to the left. So you have the 3 data, you can find what D is. I already told you what L was. All right. So I think we're good. You have D, you have L, and you clearly know that you're dealing with a red laser, right? So it's up to you to Google what the wavelength of a red laser is in order to know lambda. So you have lambda, you have L, and you can find D. So I'm waiting for you to find, no, you can find Y, Y is the distance between the bright fringes. You can solve Y based on the zoom I just did. So you have Y, you have uppercase L, and you have lambda. You can use that to solve for D, which is the size of the grooves, okay? All right.